Hello everyone, my name is Janne Kivinen and I work as a product manager at Fastems, and today I am here to tell you about the 6 solution blocks for economical small batch production. And later during this presentation you will learn what first of all what this economical small batch production actually mean. And a couple of words about my background. So I am Master of Science in Production Engineering, and previously I have worked at Fastems as a technical support person, and then also I have trained our customers, so I have been a customer trainer, and that's why I have quite a practical approach to the our offering and our customers' production. So I know pretty well how our customers are using our systems and so on. And my home office is located in Finland, in Espoo, and Espoo is in the capital area of Finland. If you don't know the geographics of Finland that well. And a couple of words about the schedule. So first of all, we have 30 minutes for the presentation, and then we have 15 minutes for the Q&A. And you can send those questions through the questions menu during the presentation. And the presentation topics are that I will first introduce Fastems as a company to you shortly. So what kind of company Fastems is and what we are doing. And then I will explain what this economical small batch production actually mean. And then we will go to the actual topic of today, which are these 6 solution blocks that will help you to achieve this economical small batch production. And now we could start with the Fastems company presentation. So Fastems is a Finnish family-owned company, and we have around 450 employees. And the main products we are delivering are different flexible automation solutions for metal cutting industry or metal cutting machine tools basically. And nowadays our offering is more and more focused on the software side also, but Fastems is anyway able to deliver both the hardware, the automation hardware, and then the intelligent MMS manufacturing management software to all our products. And that's it basically. Now you know a bit better what Fastems is all about, and today you will learn more, especially about our software MMS. And I work as a product manager of digital offering, which basically means this MMS manufacturing management software. All right. Now, as promised, I could explain to you a bit what this economical small batch production actually is. And a good starting point for this discussion is the machine tool. So usually the machine shop owner wants to see the red light, green light on the top of the machine as much as possible. And we at Fastems see it this way, that the company wants to do right things, right time, all the time with this machine. And because Fastems is an automation company, and we have worked in this industry almost 40 years now, this all the time thinking is maybe the first thing that comes into your mind when you are talking about automation. And so you want that the spindles are making those parts all the time, around the clock, or 8, 7, 60 hours a year, like we at Fastems like to say it. But actually, during recent years, we have seen the shift in this picture to the left. So now our customers are more and more considering these right things, right time kind of things also. So they want to do the right parts at the right time, and the economical small batch production is just this. So how to get these 3 variables right at the same time. And the next slide maybe describes a bit better how the what this economical small batch production actually is. So we can first take a look on the traditional batch production where the company is making those parts more than has been ordered by the customer. So we make big batches and try to achieve economic of scale through that. And this helps us to keep the utilization of the machines high, and it also decreases the setup times because we don't have to make those setups that often. And also our production planning is a bit easier because we have then always parts in stock, because usually making more parts that has been ordered means that we produce parts also to stock, and then when customer orders something, we don't have to do immediate production planning because we can deliver those parts from the stock. So these are the upsides of this batch production. But then the downsides are that the work in progress is higher because we are making bigger batches and more than is needed. And the same thing is with the lead time, because those machines are making parts to the stock instead of parts that we could deliver to the customer tomorrow, for example. So that's why the lead times of our orders is longer. And then the stock value goes up also, and this of course means a risk if customer never orders us those parts anymore that we have previously produced to the stock. So this is the first way to do the production, the batch production. Okay, there are some upsides, but there are also downsides. The second method is this conventional small batch production. So then what happens when we start reducing the batch size? Okay, or work in progress goes down, because then we are producing just those parts that are needed, and this means smaller batch sizes compared to the batch production that was presented in the first section. Our lead times are also shorter from the same reason, and then our stock value goes down, so we don't have to tie our capital to those parts that are laying around in the stock. But okay, what happens to the performance of the manufacturing process? First of all, our machine utilization usually goes down, and the reason is that the setup times or the amount of setup work goes up in the production, because we must do more and more setups, and then the machines are spending more and more time doors open on the machine shop floor without making any parts, without making any money to the company. And the last thing, time used for production planning. So now in this method, the life of a production planner can get tricky, because there's no stock, and the company is really struggling to achieve all those production goals customers are setting. So customers are ordering parts in random order, and then this makes production planners' life quite challenging. Okay, full optimization. It means that we take the best sides of both worlds. So basically we are able to produce just those parts that are ordered by our customers, and we are able to do it in an efficient way. And now you are asking that how to do this, how to achieve the best sides from the both worlds, and this is what we're going to find out during this presentation. And the solution consists from 6 blocks, which are the production planning, production start setup, tool management, transfers and loadings between the process steps, quality and traceability, and machine tools. And now I will go these steps through block by block, and then after this we can have some discussion in the Q&A session. First one is the production planning, and the typical production planning challenges are that there is a lot of manual planning work. So if the production planning is done using some manual planning tool like Excel, for example. And it gets even more challenging when there are changes happening all the time. So customers are sending new orders in, or they are postponing orders, they are modifying the orders, and so on. The due dates are changing. Those kind of things. This is something that happens every day on the shop floor, or in the shop machine shop office. And then the lead times are also hard to estimate. So there is no real transparency to the production. What is happening there on the factory floor? And then this becomes even more difficult when we start reducing the batch sizes, because smaller batches mean usually also more batches, and then the production planning gets more complex. So what to do? How to solve this problem? Okay, the first part is of course the ERP. So the ERP system includes all the production orders, and now when the new production order is added to the ERP with the certain delivery time and with the certain quantity, the key here is that then there should be this kind of automatic production planning software available, where these production orders can be sent either through the interface, ERP interface, or manually through the user interface of this planning tool. And what happens next is that there is this pre-saved part data in the system, which basically means that the instructions or the receipt, how the part can be manufactured in the factory or in the system. So it includes all the operations, and here I have one example. So it could include the sewing operation, turning, grinding, and inspection operations. And after those operations, the part is ready to be shipped to the customer. So now when the software has the information that how many parts are needed and when, and then on the other hand the part data, what kind of things must be done in the production process. By combining these two, the software is able to calculate the optimal production plan, and if something changes in the orders, we can automatically reorganize the production plan, and then you have always up-to-date work lists and work queue for the production machines and operators. So this was the first block to make the production planning process quite a bit easier with this kind of planning software. Okay, the second block, production start setup. So first, we could take a look on what the setup actually mean, the production setup. So the setup is some kind of work or preparation that is needed between two different jobs. Sometimes it can be minutes, sometimes it can be days. So it varies depending on the production situation. And if we take a look on the things that must be done within each setup work, first there's the tooling. So the machine operator must search the right tools and measure them and add them to the magazine. The next thing is the work holding. So fixtures or some clamping elements that must be used to clamp the parts to the machine. The raw materials must be fetched somewhere, and then the NC program. So where is the program? Is it in the machine or in the CAM server or somewhere else? And then we must validate the process. So usually this is an iterative process. It takes a couple of runs, and after that we can be sure that the parts are the highest quality we can deliver. And only after that we can start producing the parts at full speed. So the setup time can actually be seen as one of the biggest obstacles in moving into smaller batch sizes. And I have heard this from one production manager's mouth, that sometimes I feel that my production is driven by setups instead of orders. So basically this means that sometimes the setups are defining that what parts are manufactured next. So it can be, for example, the machine operator is thinking that now I am producing this job A, and next I should start producing job B. But actually the setup work from job A to job C is much easier. So I will do that at this point instead of job B. And then this leads to situation that the critical job, which may be critical job, this job B, can get delayed because of this selection of individual operator. So the setup time really matters there on the factory floor. And we must remember that the setup time does not add any value to the part. So usually that's like unnecessary evil there to do the setup before we can start actually cutting material, for example, with the machine tool. And it has also great potential for the errors and mistakes. So when humans are doing things, it's possible that the tool offset is, for example, written wrong, or the work holding is not properly installed to the machine. Those kind of things can happen. And as we have learned, smaller batches can mean also more setups. And this, on the other hand, leads to lower output and utilization. So what to do? How to reduce the setup work? First one is the work holding. We must consider using smart work holding methods and technologies such as the 0-point elements, which allows really quick changeover between different kind of fixtures without stopping the machine for too long time. And also we shouldn't forget the meaning of standardized work and the proper instructions, so that the operators always know what to do with each work holding or each setup. The tooling is another thing. It should be clear for the operator how to check which tools are needed. Do I have them in the machine or not? And then we should also make the tool presetting process as efficient as possible. And I will have a slide about this also later in this presentation. And then the third component is the NC program. So operator must know which program to use, which NC program version to use, and also know when the NC program was last time used. So is there something that should be fixed before I can run the program? So these three elements. And when we talk about flexible automation, it's just about getting these three things right at the first time. So with the flexible automation, we can kind of save the setup for later use, and then it's available whenever needed. And then this way we can achieve the highest quality and performance, production performance right from the start, or right from the first run. So then we have different kinds of automation for different kind of needs. So whether it's a pallet-based automation or part handling based automation. Third component is the tool management. And here we can see some tool management challenges. So it's sometimes difficult to check if we have all the tools in the magazine to run the job or not. And there are all the time sudden tool shortages happening, and then the machine stops, and it stopped until the new tool has been delivered to the magazine. And when we have lots of machines, this tends to happen quite often, which then is ruining the utilizations in the end. And the presetting process needs quite a lot of manual intervention and lots of repetitive tasks from the operators, and this on the other hand leaves space for human errors also. And this is also really practical thing or problem challenge on the factory floor, that the machine tools may not have enough magazine capacity available. So before running each job, we need to really carefully evaluate what we can do with these tools, or should we take something out, and this is not so clear at all points. So again, when we are making smaller batches, this comes even a bigger challenge. So what to do? And we have actually grouped the solution on 4 levels. And these solutions are now from the Fastems product portfolio. So first one is the thing that you should know which tool is needed, where and when. And then in addition also to see which tools are not needed. So this is sometimes also valuable when if we don't have large enough magazine, we can check which tools I don't need today. I can take them out and then replace those tools with some tools that are currently missing. And here we have a couple of screenshots from our MMS software. So MMS is telling also in advance to the operator when the machine will stop because of tool shortage, and also provides a clear list that this and this tool will be missing. So really basic things, but still brings a really big help for the daily work of the operator. The second step is it's about streamlining the presetting process. So it's possible to integrate the MMS software of Fastems to the machine tool under the presetter, and then the presetter can send the presetting data directly to MMS, and MMS can send it to the machine when the tool is inserted the magazine. And this is then eliminates the possibility for human errors in the process. And these 2 steps are just about the software, so no actual automation hardware is needed. But then if we go even one step further and we start talking about the automation, we have also the centralized tool storage available, and this gives even more flexibility to the tool management. So then you can first of all extend the magazine capacity a lot, and then you can share the tools between the machine tools. So for example, if there are special tooling, custom-made tooling, which is usually very expensive, those tools can be shared between the machines, so you don't have to purchase this special tool for each machine in the machine shop. And then if we go even one step further, there is this tool service cell, where then the robot is taking care of the presetting process also. So only job the operator must do is to change the inserts of the tools, and the robot and the automation will take care of the rest. So really, this is some heavy duty tool management solution already. The fourth element, it's about the transfers and loadings between the process steps. So usually there's quite a bit of waiting time between the process phases, and usually those are also it's a careful process to load the parts to the process, and this can on the other hand slow down the production flow, and there is usually the manual interventions create the quality risk to the process, and the situational awareness that where are the parts and where are they going next, and why they are not going there, or why they are not already there. So these kind of questions can be asked. And again, when we have more things going on the factory floor, we make smaller batches. This tends to get even more difficult. And now here I have listed some of the processes of a typical machine shop. So there's the machining process itself. There is some turning. There is grinding, washing, surface treatment, finishing processes, visual inspection, and so on. So quite a lot of processes. And all these processes can actually be integrated to the flexible automation. So FMS or flexible automation is not only about integrating the machine tools, it's also about integrating the other processes like these ones visible here. And then the FMS or other flexible automation solution takes care of delivering the parts from one process phase to another, and this way we can really minimize the waiting times between the process phases. And nowadays our MMS control is also able to manage the production phases that are done outside the automation. So then if, for example, the saw is supplying the materials to the FMS, we can then take that also under the same control and tell for the saw operator that what to do next and where the sawed parts must be taken next. So everybody on the factory floor have the awareness what is happening and what I should do next. Fifth step, it's about the quality and traceability, and these are the typical quality and traceability challenges. So the manual work phases usually cause some variation to the process because people have different methods to work, for example. And the traceability, if there's a need for traceability, like it's usually the case, for example, in the aerospace industry, this increases the production costs. So to implement the traceability and the quality management to the process. And it's also this question that if the cost of failure is high, then we start running the production slower than we should, because we want to make sure that nothing goes wrong. But then we can think that which one is more expensive. We run the production all the time slowly, or then there is the risk for the quality issue. So both scenarios are not that positive. We lose money in both cases. And again, what we can do? Okay, the solution elements are that we should make the production process, first of all, as reproducible as possible. So do the things the same way always. And we should integrate the traceability into the process so that no additional work is needed from the operators to keep the traceability available. And the drawings and other documentation should be easily available whenever needed. And the quality issues should be easy to report. And what kind of benefits the intelligent flexible automation can bring to this? So first of all, we can save the part receipt into the automation software. So things are done always the same way. And we can also integrate the traceability to the process. So we can collect the traceability data, for example, send and then send the data to some external quality management system, for example. And we can make the production documents easily available through our interfaces, and this can be loaded also from the PDM if that software is in use. And then it's also possible for the operators to report the scrap reasons to the software, and then it's easy to do some statistics or statistical analysis that what has caused the scrap parts there in the production. So here's one example from our MMS software, these scrap reasons. So there has been material fault or clamping error or tool breakage that has caused some loss for our production. The last bit is the machine tools. So if we take two short viewed machine investment or a way to invest to the machines, it can lead to dedicated machines. And this is of course bad if something happens for that dedicated machine, then we have no other machine that we can use to machine those parts. And then it may also lead to increased investments in the machine tools, because every time you need to do some new kinds of parts, you need to buy a new machine. And the tool setup challenges when the amount of needed tools is high. So if we don't have large enough magazines to take all the tools we need to run every job, that is also a challenge. Labor challenges. So if there are machines with different controllers, it's really difficult to manage from the operator resourcing point of view. So I have collected here some list of things that you should consider when making the machine tool investments. And well, I'm not a professional on the machine tool side, but I have but these are what I have seen and I found important when talking about the machines, and especially machines that are used in a flexible production or economical small batch production. First of all is the machine size and the capabilities. So you should think about the envelope in a way, how big parts or small parts you want to run with the system, and this is or with the machine. So this is of course quite basic thing. What size of a machine you need now and in the future, and then of course the how many axes the system has. Is it 3, 4, or 5 axis machine? And then the similar machines thing. So it's nice to have similar machines on the shop floor, which gives you certain flexibility, and you can use alternative machines. So if one machine is not available, you can use another one, and it's also then makes it possible to scale up the capacity easily when you can produce the same part using two machines at the same time, for example. And then it makes the operator resourcing easier, because then one operator doesn't have to know all the tricks of all the machine tool brands. Magazine size, you should have enough pots for sister tools also if you want to run some lights out production. The tool numbering, I have highlighted this, so it would be it's good to have tool numbers that are not based on pot numbers. So they only like this you can use the sister tools in the process. And the machine connectivity, you should consider having some interfacing capabilities with the other production data systems, including the automation compatibility. So these were the 6 solution blocks, and now I went them through really quickly. The final words I like to say to you is that there is no automation or software that would solve all the challenges on their own. So this change is also about the organization, so and the people. So every people in the process must understand that what is needed to achieve the best possible result, and then the software and automation can bring great help after the people working in the factory have understood that what is important, so that we can deliver the parts we have promised to our customer. And these are just examples I have shown today, and you don't have to implement everything at once. So you can start with small steps, maybe implement some production planning software, and after that start tackling the tool management and so on. And anyway, Fastems and Fastems experts are available if you want to talk about more about the economical small batch production or flexible automation. So we are happy to help you and maybe give you some live demonstration of our MMS capabilities also. I want to thank you at this point. I have exceeded my time by 5 minutes. Sorry about that. And now we have some time for the questions. So let's see what kind of questions we have received actually.
So Janne, so I take over for a couple of seconds that you can look in the question part. So
Sure.
First of all, thank you very much for the presentation. Now it's time for the Q&A part, dear attendees. So it's your turn. Enter your questions now if you haven't done it yet. So take the opportunity and ask your questions. So, and now I hand over to Janne.
Yeah, thank you. So yeah, we have actually received a couple of questions, and the first one is about that can I integrate different machine tool brands or NC control under the same Fastems system? And the answer is yes. So Fastems is an open integrator, and that means that we can integrate all kinds of machine tool brands under the same system. So it's possible to have even different brands under the same system. So that is something we are doing all the time, and it's totally doable. And then of course we need to carefully evaluate what kind of interfacing is possible with each machine tool. So of course then if it's an existing machine, for example, you're planning to integrate, then we need to check that what kind of interfacing capabilities have been activated on the machine side. But this is a dialogue where Fastems can then bring you also help, and we can figure out what can be done. Let's see what other things people have asked. So how can your MMS control communicate with the ERP? Can I send my part data from ERP also? So yes, so we have interface available between the MMS and ERP. So we have a standard interface specification for that, and that allows customer to send the order data from MMS to the ERP. I'm sorry, from ERP to MMS. But it also we have just launched a new version from the interface, and in this version, it's nowadays also possible to integrate or send the part data. If you have it in the ERP, you can send it to the MMS also through the interface. And then MMS can also send some feedback back to the ERP when the production orders have been completed, including that how many hours or minutes were used to produce each operation and so on. So then this information can be used for example, when calculating the profitability of the orders we have delivered. Then we know how many hours we actually used to deliver the order. Let's see what else. Okay, there is still one question, and it's about the traceability. So how is the traceability integrated to the system in practice? So okay, the whole traceability topic, it's usually quite customer specific, because the customers usually have their own requirements for the traceability, and Fastems has delivered or implemented several different levels of traceability solutions, and then it really depends on the case what kind of how the traceability works in practice. But there are different alternatives, like if it's like a lot-based traceability, that there is certain lot number for the one order, or then is it really so that one part is totally unique and it has its own serial number. So then usually, for example, in the aerospace sector, we are talking about this kind of traceability, really high requirements. And then another example is that we can send some data to the machine also, and then, for example, the serial number, and then the machine based on this information can engrave the serial number to the part also. So that kind of things we have also delivered. But in short, it's really case specific, depending on the requirements of the customer, how the traceability is then implemented. But like already said, Fastems professionals are happy to discuss about this topic, and what kind of traceability solution, an automation solution could be used in each case. Okay, I assume at least now I cannot see any more questions. Let's see. Okay, there is actually one more. What do you mean for small batch? 1, 10 or 100 pieces? So that's a good question actually. So and that depends on the case also. It's the most ultimate batch size is of course batch size 1. So then that's like the ultimate challenge for the flexibility of the system. That if there's only batch size of 1, is the system able to do it efficiently? And we have also customers that are producing unique parts with the automation. So for example, in the mold making industry, we have customers where each part is a unique part, and then that sets really high requirements for the flexibility of the system. But then it's also it depends on the industry. If it's like a automotive industry, and if we talk about batch size of 100 pieces per batch, from the automotive point of view, it's a small batch, even though in the aerospace industry it can be a huge batch already. So it really depends on the case and on the industry. But we have anyway experiences also from the batch size 1 kind of production, but then we have also systems that are making quite high annual volumes of each part. And that's also one part of the flexibility, that then the system is able to scale up the capacity, production capacity if needed. So if we have those alternative or parallel machines, we can use several machines at the same time to speed up the progress of some order if needed. But that was a good question. I didn't mention any figures about the batch size. All right. Is there still? Yeah. So there is one more question about the presetting. That can Fastems automate the tool presetting also? Yes, that's also possible nowadays. So we have this solution, tool service cell, and that we can use then to automate the presetting process. But like I said during the presentation, it's quite high-end automation already, and then the case, or it must be evaluated case by case, how many tools and what kind of tools should be preset and so on. But anyway, we have also solutions for that, and we are happy to discuss if you are interested. All right.
There is no other question left.
Yeah. Okay.
Maybe you would like to say some final words to the
Yeah.
attendees.
Sure. So again, thanks for your interest and time, and thank you for participating this webinar. And I hope this brought you some ideas how to develop your production. And you can contact me or my Fastems colleagues, and we can continue the chat. So thank you, and have a good day.